Okay, a spaceship has left the Earth's orbit and it on its way to the moon. The spaceship is moved to the moon. It accelerates 20 meter per second square is acceleration, and the time is 2. And cover a distance. Let me a distance is x or x. What are the initial and final velocity of the spaceships? If we know the initial velocity, that's question is they are given for the distance. Let me write down this at x, no x, that's a delta x. So let me think. If you use the one of the equation that x equal to v square, let me write down the first. V square equal to v naught square plus 2a delta x. Okay, if I write down, but for this equation, we still don't know initial velocity, also the initial and final velocity. We still don't know. That's maybe that this will be the last equation we have to find if we know the initial velocity first, and then we can move to the final velocity, right? So now we can use the next equation. So what is that? X equal to x naught plus v naught t plus half a t square, right? Okay, for this one, we can use the x minus x naught is they are given is 1000 kilometer. We can use, and then acceleration is 20, and the time is also given. So from this equation we definitely we can find the initial velocity. Okay, let me write down. The x naught is 0 because it's a starting point. X is they are given 1000 kilometer. Let me change to the 1000 meter, and then equal to v naught t. V naught is what we want to get, and then into time is given is 2 minutes. Okay, 2 minutes we need to change to the, if we want to get the meter per second unit, because we are the given ones acceleration is meter per second. So we need to change the time. I will move here. 2 minutes equal to this very easy, 120 seconds, right? So 120 times plus one half into acceleration is 20 times. This one is 120 the whole square. So from this equation, we will get the initial velocity. Okay, let me equal to. Okay, the answer velocity for the initial velocity, the answer is 7133.33 meter per second. Okay, the first I got initial velocity, and then as we previously mentioned, we can use the v square equal to v naught square plus 2a. We can use, but from you can also use the first equation, this one, x equal to x naught plus vt. No, this one not. This one, the third equation, you can use the for this part, you can use the third equations or the fifth equation. You can use whatever you want. Now I want to use the fifth equation. V square equal to v naught square plus v naught square is 7133.33 plus 2 times acceleration is 20 into x is 1000 times 1000. Okay, let me check. The answer is 9533.33 meter per second.